Hello, hi, this is Ramohan. I am working as head of electronics department at Government Polytechnic, Nagar. The subject we are handling here is the basic electrical and electronics engineering. The topic of our discussion is inductors and the transformers. The subtopic for this session will be on the different types of the transformers. So the objective of this session is this. So on the completion of this session, you will be able to know the different types of the transformers that are available. So let us recap. Can you give the relation between the voltage, current and the turns ratio of a transformer? Yes, so this is E2 by E1, that is secondary voltage by primary voltage, is equal to secondary turns, number of turns in the secondary winding, to the number of turns in the primary winding, and the which in turn is equated to current flowing in the primary and current flowing to the ratio of current flowing in the secondary, that is equal to K, where K is called as the turns ratio of the transformer. Now let us see one more point for us to recap our discussions. A single phase transformer has a 400 primary turns and 1000 secondary turns in, and then what is the transformation ratio? So you have primary 400, second is 1000, and K is equal, he is asking about K, the transformer ratio. So K is equal to N2 by N1. So it will be 1000 divided by 400, so you will be getting it as 2.5 is the transformation ratio of the transformer. The current ratio is, for an ideal transformer, the primary volt ampere is equal to the secondary volt amperes. So we are talking about the power rather, because this is a source of power going to give us energy. We call it or express it as a volt ampere of the transformer, whereas for a load we refer it as the power consumed, rather it is expressed in watts, and usually the source or a supply of power is indicated as VA, volt amperes. So here for the, it is the volt amperes of the transformer. So input power is equal to output power, and input power is E1 into I1, that is primary voltage into primary current, and that is equal to E2 into I2, that is secondary voltage into secondary current. So that is, so thereby doing some transformation we get as E1 by E2 is equal to I2 by I1, that is equal to 1 by K. So this is called as the current ratio of the transformer. And let us see the relation between the voltage, current and the turns ratio of a transformer. So just now we have actually recalled that. So the current, voltage and the number of turns related to one another in the primary and the secondary of a transformer are as below. We are going to write the expression of, it is E2 by E1 is equal to N2 by N1, that is equal to I1 by I2, and that is equal to K. So K is the transformation ratio. So this is the basic principle underlying the operation of all the transformers. The different types of transformers. Let us see now. Our basic objective of this session is to know about the different types of the transformers. On the basis of the core metal is used for the transformers manufacturing, they are broadly divided into two categories, that is air core transformers as we can see this in the figure, there will not be any physical core. So the core present is air core, and the primary winding and secondary winding will be placed in the vicinity of the magnetic field or the magnetic flux of the coil. So then there will be interaction between the two coils, and then it works. And the next one is the iron core transformers. So these are very commonly used power transformers, what is shown in the figure. So the core, the primary and the secondary windings are linked up with a iron core. So that will link both the circuits through the magnetic circuit or the magnetic flux flowing through the core of the transformer. Then different types of the transformers. On the basis of the winding, they are actually divided into core type transformer, as you can see like this. So there is core, so it is wounded on the core. Then core model of transformer, as you can see, there will be two arms in the magnetic circuit, and each winding of primary and the secondary will be wounded on each leg of the core, and that is how it is. And let us see the other one. It is called as a shell type of transformer, and the shell type we have seen, it is like E and I, a very standard and regular transformer what we usually come across in electronics power supplies. So this is how it looks like. So there will be primary winding and there will be an outer. So they are, most of the time they are step down transformers in our electronics. I mean, again based on the, so we are actually going to see the classifications based on the basic of the function of the transformer. So they are classified as voltage transformers. So this is what we commonly come across as the application of the transformer. So the moment you call a transformer, we'll be recollecting with respect to voltage most of the times. Yes, voltage transformers. So it is used to change the magnitude of the voltage. So by properly maintaining the turns ratio, that is N2 by N1 and V2 by V1, we can achieve this voltage transformation ratio. So in for normal applications for household and all, we'll be using it for step down, and whereas for the transmission purpose of the power, we step them up. So once it is generated, and actually we have to increase the voltage for transmission. Why? Because there, by increasing the voltage, the current factor comes down. So when the current is less, the power losses, that is the losses along the transmission line, which are I square R losses, they will be minimum, and that is the very purpose of our increasing the voltage for transmission. But whereas for the electronics to work, we have to step down, because we operate electronics, people operate at small voltages like 12, 6, 5, 3, like that. So this is what the transformers are for voltage transformation ratio. So the main criteria will be to change the voltage trans ratio. So these are the models we can see. So most of the time they are actually looking like step down transformers alone. Sometimes even in actually televisions wherein we require, and cathode ray oscilloscopes, we also require a voltage of about 20 volts, 25 kilovolts, sorry, 20,000 volts and 25,000 volts. So that also will be achieved by using a transformers by small different techniques. Let us see, we'll see them. So broadly they are classified about based on the function into as voltage transformers, then current transformers. So here it is used to change the magnitude of the current from primary to the secondary or vice versa. So that is most of the time used in industrial and high current applications. They look like this. Then we also use them for impedance matching transformers. So we basically know by maximum power transfer theorem that the maximum power will be transferred to the load to the next circuit when there is perfect impedance matching. So when there is an imbalance in the matching, we use sometimes this transformer to couple the signal from one stage to the other stage or the next section. So here you can see, so that is used to match the output impedance of one circuit with the input impedance of the next circuit. So here you can see sometime they are used in radios mostly. So and this is the technique from balance to imbalance. So this is an impedance matching transformer which is matching its impedance to 75 ohms. And so this is a radio receiver. Of course you don't see now, that's a very old one, but this is standard very good one. Here you can see the transformer, and that is actually working at audio frequencies, and that is the final stage of this audio amplifier of this radio receiver. Why? Because from the output of this transformer the signal audio signal will be coupled to the loudspeaker. So this is also actually matching the impedance with the speaker. So that is a loudspeaker which is fixed with the cone or the face of the speaker on the other side. So we are looking at the magnetic coil side. So this transformer shown by the yellow arrow is AF transformer, and that is achieving the function of impedance matching, and it is matching the impedance of 8 ohms with that of the loudspeaker that is used in the circuit. So that is the final stage of this radio receiver or the audio section of the receiver. Then let us see some more types. Now that is the isolation type of transformers. So here some transformers are also used for isolation purely. So because one circuit and the other circuit connected to primary and the secondary circuit, they are not electrically connected. They are isolated, but they are connected magnetically. So they are used to prove isolation between two circuits without changing the electrical parameters of the signal. So the electrical parameters of the signals will hold good, but signal from one side of the circuit, that is primary, will be perfectly transmitted to the secondary side of the circuit which is connected to the secondary winding. So well, it depends on the application. So just now we have seen an application wherein the primary side of the impedance transformer, that is audio frequency transformer in a radio receiver, is coming from the output of a audio amplifier circuit. So that circuit is going to deliver the amplified audio signal, and the output is connected to this loudspeaker. So when the audio signal waves are coupled or connected to the winding of the speaker, so it vibrates according to the signal that is input to the transformer. So it produces the sound waves proportional to the signal that is coming from the audio amplifier. So but they are perfectly isolated. The coupling is only due to magnetic circuit happening in the transformer. So this is an isolation transformer. So a transformer normally produces isolation perfectly between the two circuits. We also use the transformer for instrument transformers. So they are used to measure the voltage and the current. In instrumentation, the transformer is used. So without actually, suppose there are high voltages and high currents flowing in the circuit, so we cannot handle them directly. So by using an instrument transformer, so we'll see a model of that, of course. So that will be sampling the signal that is flowing through the line or the circuit where we are attempting to check it or make a measurement. So we can either measure a voltage or a current. So in instrument transformers, they are used for measuring of voltage as well as currents. So they look like this. So here you can see, and there are a few more models. Again, on the basis of frequency, we have broad classification into power transformers, which works at low frequencies, that is 50 hertz only, which is the line frequency. No, and in all applications at different voltage levels, the line frequency will remain same. So, and they are actually, because working at 50 hertz, they are meant for power applications or power transmission stages or receiving stages, and these are hence referred as the power transformers. And they look like this. They are used to change the line voltage, as I was talking to you about this little previously, little before. So in the transmission of electricity to our household, that is, so basic is, we know it is three phase, so that will be at 440 volts, and we all operate at 220 volts at household voltages. So that is a step down power transformer, and we know how it looks like. So the transformer, this most of you might have seen this. So there are three main poles in the middle, you can see that is a three-phase connection. So there will be a transformer at every corner of one lane, and it will be receiving about 440 volts three phase. Then that will be stepped down to 220 volts or 240 volts, and that is the line voltage, and that will be supplied to the household purposes consumers. Then you have audio transformers, which just we have discussed. So they are used in the to transfer the electric signal of the audio frequency range, that is from 20 hertz to 20 kilohertz. So the one what we have seen in a radio receiver is such an audio transformer. So it will transfer and work efficiently at this audio range, that is 20 hertz to 20 kilohertz, and it is useful for, so just now we have seen that it is meant for transferring from audio amplifier to the load, that is a loudspeaker. So that's the main purpose of a audio AF transformers. So again, this is a radio receiver, and here on this is another model, but of course, so here also you can see there are two transformers, and one of them is, or both of them can be of AF range, because there will be two stages of push-pull configuration generally in the older model of radio receivers. So in a push-pull mode, we also use power supply to couple the input signal to the amplifier base, and again from the output also you need one more transformer to connect the load. So the output collectors are coupled or biased through a transformer, and the secondary of the transformer will be collecting the amplified audio signal, which in turn is connected to the loudspeaker in a radio receiver. So and that's the reason why here you have two transformers. One is for input signal application to the push-pull configuration, and again from the push-pull you will be connecting to the single load, that is the loudspeaker. So this is how it is there in the radio receiver application. further let us continue with the different types of the transformers. So we also have classifications on the band of frequencies which they work efficiently for. So depending on the frequency band they work, band I'm talking about the width of the channel or the frequencies, they can work efficiently. So now they are classified as narrow band transformers and wide band transformers. So in the radio frequency and IF transformers, they come under this category of narrow band transformer. For example, in a radio receiver, you have the RF amplifier as the first circuit or the input circuit for the radio receiver. So here we are interested in, see, our radio receiver is going to work from 550 kilohertz to 650 or say almost 1800 kilohertz, and our audio frequency range is only 20 kilohertz. And for the purpose of selecting any station, one particular station to be received, so we use a tuner circuit, and therein the transformer that is used will be, it has to be a narrow band transformer which works at only 20 kilohertz width. So at every station you are going to select, the width it has to work efficiently is only 20 kilohertz. So this is the purpose of a narrow band transformer. Again, they are also used in IF transformers. IFTs you call in radio receivers. So once the signal is received, and then we'll pass it through a mixer, super heterodyne that, then the resultant frequency coming out of the mixer will be 455 kilohertz. That is a standard intermediate frequency range. From there onwards, you will be having these IFTs to couple between the different stages from stage 1 to class A, class B, class C, and then finally a power amplifier, normally a push pull in the radio receiver, just we have seen in the previous discussions or the previous slides as well. So here these are the IFTs that are used in radio receivers, and they'll be having a bandwidth of only 20 kilohertz, and the frequency they are going to work at is 455 kilohertz is the central frequency of these IF transformers. Now let us see the next one, that is the wideband transformers. So these are the things, that is video and the pulse transformers come under this category. So video amplifier will be working at very high frequency, and the bandwidth required for video amplification is 5 megahertz. And for pulse transformers, that is for triggering purpose of SCRs and other firing devices like IGBTs, thyristors, so on. So we'll be using a pulse, triggering pulse. So the transformer use it for isolation. See here also, because the thyristors work at high voltages and peak currents, hundreds of amperes, thousands of volts. So we'll be using transformer mainly for isolation, and then also we need to apply the signal to the next stage. So for that purpose we'll be using these video transformers. They look like this. Let us see one more model as well. So now we are actually trying to see a pulse transformer here. So let us see this pulse transformer. So here this is actually a UPS circuit working at very high voltage, and there are about 6 IGBTs, and these are the pulse transformers. So here they are actually used for in the UPS for triggering of the SCRs or IGBTs. So insulated gate thyristors. Okay, so they are FETs, actually they are the firing devices that are used in UPS, so they all work for this. So on the basis of the current ratings, they are actually divided into high current transformers and the low current transformers. So yeah, let us see some models about this of the transformers. So this is the principle of working of a current transformer. So yeah, so they are actually used for instrumentation as well, to sense the current that is passing through it. We'll see the models different ways, and this is the basic principle for the current transformer working. So there is a line that is power conductor, you can see in the left side figure, and you have a coil that is our secondary terminals to measure the instrument. So that is one method, and right side also you can see there's a main line that is flowing, and then you have a winding on the secondary that is written as CT for current transformer. And so this will actually sample the current that is flowing from the primary, and then properly accordingly we will calibrate the ammeter. So this is again used for measurement purposes. And this is one model of a current transformer, what you can see here at that one. And these are different models. So with actually on the circular ring model only, on the top side you can see a glass capsule sort of thing, so that is meant to fix over the cable. So we'll open it, slit open, then put it over the cable like in the circuit there on the left side you can see. So these are different models and different voltage and current ratings of the current transformer that are used. So different types of the current transformers here you can see, and different age. And left side also, bottom you can see there is a right square hole. So the rating written over there is the 20 amperes of current. And again on the top side, on the first row right side, you have three instruments. They are actually called as the clamp meters. So actually we'll be putting one conductor into that ring. You have a facility to break or to open that clamp. We'll pull one conductor wire into that, leave into the clamp, and once you turn this on the or the load to the cable, and we'll turn on this will be measuring the current. So the right side three are the basic principle of current transformer used for measuring current in a circuit. So some more models here. So this is here one you can see, that is 33 kilovolts current transformer. You can see the writing, it is 33,000 volts. And then you have one more which is working at 1000 volts and 5 amperes of current. There is another one model which is working at 100 volts and 5 amperes of current. So these are different models that are available in the market for various applications and the ranges. So with that we'll conclude this section about the different types of transformers. So as a summary, we have discussed in the summary, let us see what we have done or covered so far. So we have discussed about the different types of transformers. It's like the classification, like voltage transformers, current transformers, stepped up, step down, instrument transformers, impedance matching, narrow band, wide band, and at different frequencies. RF working at 50 hertz, again IF frequencies, then video frequencies, so etc. So that is what we have actually discussed in all the sessions till now. Let us see a small quiz that is meant for our memory check. Dash transformer is used to change the magnitude of the voltage. A voltage transformer, a current transformer, or power transformers, or any of the above for changing the voltage magnitude. So that is the voltage transformer. So we use a voltage transformer to change the magnitude of a voltage, so either step up or step down. Let us see the next one. Dash transformer is used to change the magnitude of the current. A current transformer is used to change the magnitude of a current. So by properly adjusting the turns ratio and the windings, you will get the current, required current to be delivered in the secondary of the transformer. Next one, dash often used to change the magnitude of the current. So it has to be current transformer again. It is a current transformer. Now let us see some frequently asked questions in the topics we have discussed so far. So give the classifications of the transformers. So with that we have come to the conclusion of this session. So wherein we have actually discussed the different types of transformers that are available in the market. And thank you for being with me. We have also seen some quiz, some mostly asked questions in the examination part of view. So thank you very much everyone for being here for this session. Thanks a lot.